All right, I think we're good to go ahead and get started here. So the organizer did ask me if you guys would be comfortable moving forward. I'm totally cool if you want to remain spread out, but it's up to you. But they'd ask me if it'd be cool if we could move everybody forward just so it's a little bit closer up here. So if you're comfortable moving, awesome. If you're not, feel free to stay where you are. So cool. So for this presentation, I have a few slides talking about what we're going to cover today and who I am. Just looking at time. And so we'll get started here. The key takeaways, though, I just sort of want to preface this talk. Really, what I want you guys to walk away with is sort of just an understanding of how to integrate LLMs and AI with your applications, and sort of just encourage you to have the terminology, some basic principles and design guidelines you could follow in building things with AI. There is a demonstration component. I do have some source code that you can all download and run. It just requires an OpenAI LLM key. And while I'm on the topic, I'm not affiliated with them anyway. I'm just kind of me. But I do reference OpenAI. I have some screenshots from some of the things they provide, like a tokenizer. In my opinion, they have some of the best models. You may disagree, in like Gemini or Anthropic or Claude or any of those things, or companies. So just a disclaimer at the beginning there, right? So who am I, right? So my name's James Mountford. You can call me James. I'm a systems manager at National Louis University. We're a national university located in downtown Chicago, right across from the Art Institute, right on Michigan Avenue. They do have a campus in Tampa and 3 campuses in total in the Chicagoland area. I had a brief background in music education before coming into tech. I like to think of myself as a creative problem solver. Really enjoy triathlon, so if there's any other triathletes in here, yeah. But I'm not much more different than any of you, right? I'm just sort of a developer who sort of worked on these things, and I just want to share some insights with you. Where my sort of expertise kind of comes from is at the university, we've already experimented with building some applications internally that use LLMs. So the first one we created was literally a chatbot that you could ask it questions about a student record. So you'd put in an identifier, so say a student ID, or you could do an email if you'd like, but we chose ID because it's sort of definitive. And you could ask questions about the student's financial information, if they have holds on file, what program they're in, what courses they're currently taking. That was one project we did. Right now, we're actually next week launching a new internal advisory dashboard beta pilot, where we've created this sort of retention system that incorporates a bunch of data from different sources. But where we incorporated AI with that is it gives a persistent score and summary about the student. So how likely they are to continue their enrollment next term. And that's a really critical question for universities, right? So that's why we decided to implement it, because that's not an easy question to ask. But with the feedback capabilities that things like ChatGPT and stuff give us, it's sort of something that we can now answer at scale, or at least attempt to answer at scale to see if we can do it, right? Part of the reason we're at beta. And I've built a few personal projects. I promise the next few slides will move a little quicker than this. I built a few personal projects with it. My big one right now is I'm trying to work on sort of an AI scheduler where I can input a list of tasks. It'll distribute my workload for the week across all the days that I want to work. So I can input, I don't like to work on Saturdays, for example. So if I put in my list of tasks, I need to do X, Y, Z, my homework, I need to work on this, maybe outside of work, I need to go assist my parents with something, it'll distribute the workload for me, right? That's another use case where it's like, it'll think for me, and I can look at the data and say, I like this or I don't like it, right? But sort of that cognitive capability of it is really powerful. Yeah, so that's about me. So what are we going to discuss today? As you probably could tell, we're going to talk about LLMs, large language models, specifically as a branch of AI. We're going to talk about some design principles, some very high-level architectures, and some basic code structures just to get you guys comfortable with building these things, right? I hope that for the non-technical people here, you can leave with, like I said, terminology and still an understanding of these things so you could talk to your developers or other management staff, and for the developers to feel comfortable talking to your managers or just building these applications. We're also going to talk about use cases, business considerations. There's a lot of those, as you guys could tell from Brian's excellent keynote a little while ago. Some implementation thoughts and some challenges and insights that we kind of went through the process, or that we've gleaned through the process. So for our end goals, I want everyone, like I said, to understand the fundamentals of how they work, right? Because we can't develop things if we don't understand the tools we're using, right? That's a critical thing for me when I'm developing. I want you to leave with a grasp of basic design principles and terminology, and I really want you guys to build confidence to start experimenting with this, right? Because people are still scared about AI. They don't know, is it going to replace my job? Maybe I shouldn't work with it at all. That's not a good excuse, though, because it's like, this train is going to keep going with or without you on board, and you should get on board before the train leaves the station, right? So real quickly talk about importance, right, just to drive that point home. you could see these news articles, everyone's talking about it. I don't even need to specify this. You've probably seen so many AI articles, by now your head's probably starting to hurt, right? Talking about how important it is, how it's gonna change the way we live, how it's gonna get everyone on universal basic income, right? Which are important questions, but there's an endless amount of topics we could talk about. We see huge amounts of fundraising going into AI ventures, right? We see people already, or companies already replacing workers, right? So this is what I mean about the AI train. It's catching steam, and I want everyone to get on board, with this technology, right? People are concerned about it. Legislation's being passed. They're releasing new tools every other week, right? So it's really important that while it's still in this sort of explosive growth phase, if you can get on board, understand it, develop it, you can position yourself for really strong success as a developer, as a manager, or a leader in any of the organizations you might be a part of. So these are the 3 questions that I want everybody to consider as we go through this talk, because these are questions that I want you to form your own opinions on, because this will inform your own development processes, right? Is it revolutionary or is it transformative? By revolutionary, I mean it will upend our daily life. You will all be on universal income and nobody will work. Transformative might be, as a developer, maybe instead of me coding 100% of the time, I code 50% of the time with feedback from ChatGPT. I'm still working, I'm still employed, but my work processes have changed, right? Revolutionary or transformative. And then how can we integrate AI in an appropriate manner across our applications, right? Because there's a lot of people who just say AI, 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 but they don't really know what they want it for. They're trying to use AI to solve a problem that they haven't identified yet, right? But as developers, we know that we need to identify the problem first in order to solve it. And then finally, this is sort of a philosophical question that I encourage all of you to continue thinking about, because this is informed conversations about whether or not we want to implement it at all, right? Is what problems does it solve for our lives, our organizations, or our communities? So I hope this kind of gives you the oversight of what I'm going to try to impart on everyone today. But like I said, this is really a chance for me to give you guys some of the things that I've learned working with this tech and hopefully get some of you started with it. The only thing I forgot to ask was, for this format, we are going to move quite quickly, as you could probably tell. So I'd ask if you could hold questions until the end. I did budget about 5 to 10 minutes, so hopefully I can get to answering some of your guys' questions at the end and try to help you guys out if you have any other thoughts. So real quick, high-level overview into how large language models work, right? AI, right? We've heard this term, AI. LLMs, natural language processing, right? But what does that actually mean, right? I think when we're actually identifying the systems we want to build or how to integrate technology, we really need to stick to concrete terminology, right? Because AI has a lot of different things. It's machine learning, which could be, machine learning, natural language processing, computer vision and robotics. Those are all incredibly different fields, right? Large language models would fall under natural language processing, right? But computer vision would be being able to interpret images and give meaning to them, right? Those are 2 completely, well, not completely, but they're separate branches in artificial intelligence, right? There's also different target areas, right? There's specialized AI, there's non-specialized. We keep throwing around this term of AGI and LLMs, right? But those are all distinct terms. And it's really important that when we're talking about this technology, we specify exactly what we mean. And like I said, we're going to talk about LLMs, which fall under natural language processing. That would be the terminology I would invite you all to use when discussing how to integrate this with your applications. So quick history. There were very few advanced models in large language models. I just repeated myself, sorry. There were very few large language models prior to 2017. I believe the first model was created in the 90s by IBM, and I think they had about 300 million parameters, if I remember correctly. Right, and so there was a paper that was released in 2017 called Attention is All You Need. It was authored, I believe, by 7 Google DeepMind researchers, and that sort of transformed LLMs as we know them, right? Immediately after that paper in the following year, we saw BERT and GPT, which again, Brian had hinted at the development of those when he was giving his keynote. And then all of a sudden, we see an explosion of models from OpenAI, Microsoft, Google, Anthropic, right? So again, just emphasizing how quickly this technology is moving and why there's still time to get on board before there's a lot of catch-up to play, right? Because a lot of these things have come out in only the past 3 years. We've seen most of the developments, right? GPT 3.5 was the big one that suddenly everyone started talking about AI, right? But that was only 2 years ago. So just keep in mind the recency of all these kind of technical transformations, right? So covering a few terms that are going to be important when we're discussing this technology, right? So context, right? The conversational history, well, how I've defined this is the conversational history that's provided with each request. You can think of it like a series of chat messages. If I asked you, what did you have for lunch? I had a steak. Did you like it? That's a context, right? We've sort of framed a conversation. Tokens, right? These are quantified word slices that are parsed sequentially by LLM. So it doesn't process words. It breaks your words up into multiple different tokens, and then it processes them through some algorithms and some statistical calculations in order to actually generate the meaning, right? That's where he was talking about vectors, right? That's the actual mathematical process behind them. We don't get into the mathematics here because that is a deep dive, but just to touch on it briefly, right? Again, touching on transformers. These are networks that can process and relate words in parallel, and they're really important for handling long pieces of text, right? So they can incorporate the context of the conversation, and also, they process tokens and they generate the semantic meaning, which gets converted from tokens to vectors, vectors to tokens to words, and so on and so forth. So and like I said, that is extremely high level, and that is a deep dive. There's a lot of great YouTube tutorials online about how they actually work. But again, just giving you guys some terminology so you can start to talk about these things. Temperature, right? So value controlling output randomness. So it's from 0 to 1. If you put it 0, it tries to go with the most likely next word, right? Because we were talking about predictions. If you give it a value of 1, it'll select other words that it doesn't expect would come next, right? So how LLMs work is they say, okay, based on this text, what's the next word, the next word, the next word, the next word? And so with 0, it'll go, this is the most likely next word, right? Because it has a list of words it chooses from with percentages, right? So one word might be 75%. It's going to go with that one because it has a majority. But if you give it a 1, it might go with the word that has a 1% chance, which can lead to some drastically different conversations. So it's sort of just like controlling the creativity of the model, if you think of it that way. And again, these you might actually be more familiar with, right? Alignment. So how aligned the model is with our controlling values, right? Does it spew? And again, it's not even just this AGI concept, right? Let's separate it. Alignment. Does the chatbot represent the values of our organization correctly? Does it respond to customers in a polite tone? Does it give me information in the format that I like, right? How I process information and how I like to talk to people is different than how you might like to talk to people and receive information, right? I'm a very logical, analytical thinker. Some people are emotional thinkers, right? Or they like to think by doing, right? They're kinesthetic learners, right? So that's an important split, in the terminology where alignment isn't just about AGI and does it have humanity's best interest at heart? Does it have your organization's best interest at heart, right? And then jailbreaking, manipulating a model to act in unintended ways. You guys probably saw all the news articles in 2023 as people played around with them to get nonsense outputs and stuff like that. The funniest one I saw was, I think it was a Chevy GM dealership, put a chatbot on their website and somebody screen capped it. They managed to get it to output a Python script for a blockchain or something like that. And it was kind of crazy because you wouldn't expect that from a car dealership, right? But is it aligned with our organization? Clearly not, right? Because you're just basically subsidizing the public's ChatGPT, right? So just things to keep thinking about. And we'll touch on these terms as we keep moving around through the presentation, right? So the one thing I want to stress, and you guys probably can already tell that I want to stress this, is that large language models, they're not a black box of information, right? They use statistical calculations and predictions to guess the next word. That's why if you ever tried to have it reference a law case, if you went to ChatGPT and said, give me cases that relate to this thing, the reason why it outputs so many wrong cases is because it doesn't actually know what cases exist. It just starts putting words in front of each other that looks like a case, and that's why people get fooled into using that in, I think there was some articles about people getting caught using that in legal briefs and stuff, but the case doesn't exist, right? This is starting to make sense about how it processes information, how you can easily get fooled by the way that it looks like it has information, but it does not, right? And they, again, try to contextualize and interpret what you're saying to it through pattern recognition. Again, like I mentioned, they use statistical methods and algorithms. And again, transformers are the big technology, the transformation of words to tokens to vectors to tokens to words is how you can think about it. So tokens, right? This is how it actually generates it, right? So again, statistical calculations of the most likely to occur next token. I put in a sentence here. Ignore my typo right there, token or tokens. But this is how it processes things. And tokens aren't just words, right, or pieces of words, right? We see a period right there. We see an apostrophe S. We see whole words like each, other, from, vector, right? But look at sequentially. Sequentially, LY is a separate token, right? This is how it's actually reading what you parse it, right? Does anyone remember the strawberry question? I'm sure some of you probably looked up into why it couldn't answer the question. But do you see why it can't answer how many R's are in strawberry? It's It's because there is no token in strawberry that has 3 R's. The model would always say there are 2 R's in strawberry because berry has 2 R's, raw has 1. So it would pick strawberry as the token to interpret, and it only has 2. We know the word has 3. But that's, again, another logical failure. And they've tried to correct that in models, I think, to some sort of mixed success. But again, I think that's a really good demonstration of how they process information. So what are they good at, right? These are some of my opinions from developing with this technology. I think that they're really good at transforming data. And so what do I mean by unstructured and structured data? The JSON data on the left is literally just a customer receipt. But I would argue that it's structured, right? A machine could interpret that. We have proper syntax. We have key value pairs, right? That's structured, right? We can interpret that. Unstructured might be if I asked you, what did you have for dinner last night?
I don't even remember.
Yeah. Or if I asked you, what did you have for dinner last night? Unstructured outputs, right? I don't know what you're going to say, you know? But what if I wanted to transform that JSON string into an unstructured output, sort of similar to human, speech, right? It's really good at that. On the next slide, you'll see me punch that into ChatGPT, and you'll see what it comes back with. It's also really good at solving small, focused problems. Something I really like that Brian touched on in the keynote was talking about how we actually use these to solve problems. In my experiences, ChatGPT, he had said from an engineering perspective, right, we look for the smallest problem, and we use the smaller problems to build, the smallest solution to a problem by breaking it down to the smallest problem, solving it, and then we build bigger solutions off of those small solutions. LLMs are really good at solving really intense, focused tasks, but then if you give them wide-ranging things, you might get more creative or less defined outputs, right? Again, and also they're really good at providing interpretation or feedback. I could give an entire talk on the amount of things that I use ChatGPT with to improve communication and stuff like that. An example I'll give you is I was trying to figure out what my strengths are as a communicator, right? And so I put in some examples of communications I've had with coworkers, with personal friends, and I said, based on this, what kind of thinker am I? How do I interact with people? And it came back and it said, you're a very logical, analytical thinker, and that's what I think I am. I think other people would agree. But one of the not detracting points, but one of the critical points of feedback it gave me was that I don't respond too well to emotional communication, right? So it said you might miss emotional cues. And now for me as a communicator, it's like, I would have missed that, right? And it's like it can sort of read between the lines for me and sort of give me that feedback and interpretation. So what do they excel at, right? If you look at this JSON slide, I'll give you one chance to look at it. We have a name, a phone number, a receipt with items, right? So I'd asked it, can you please summarize that, right? So we just went from structured data to unstructured output, just human text, right? And to continue this thought about what are they good at, right? They're really good at cognitive load tasks, right? If I had asked you to look at this JSON and tell me what it means, you're going to say, okay, this is a receipt. It's Jane Doe's receipt. Here are all of her items. It just spat it back out for me in about 1 second. Could you interpret that JSON in 1 second? Right? It's good at directed and guided outputs. In this case, I had asked it, can you put out a human readable example for me, to interpret this JSON, right? And it's also good at completing these sort of high complexity tasks at scale. We'll get into scaling in a little bit later. But if I needed to parse 10,000 JSON strings, individually, how long would any developer in here, right? But with ChatGPT, I pay $1, $1.50, and they could process all of those JSON strings for me. We'll touch base on that kind of transformation a little bit later. And again, touching base on transforming data, right? That is extremely consumable, right? We went from this whole explanation with nice formatting and everything to the key points in 1 sentence, right? So again, prompting is important. We'll touch on prompting. I'll keep forward referencing a few things here, but it is really important. Use cases, right? So reducing user license counts is a big one, I think. So there is a cost to information, right? When we have people onboarded to new platforms, and when we train them to go get information from sources, there's time associated with that, right? And that, there's a time cost to training people. There's also a physical cost to that, or a tangible cost, I might say. For example, Salesforce, if any of you have had the misfortune of working with it, there is a cost associated with user licenses, right? But it costs, I think, $60 or $80 a month per user. But then the thought I had was, well, they provide APIs that return a lot of data if you just format your API calls correctly. So seeing what you'd seen about transforming that data, could we get data from the Salesforce APIs and transform it? We don't have to train them on Salesforce anymore all of a sudden. That's time saved. We don't have to pay for their user licenses. That's money saved, right? Again, so training overhead and system access requirements. Going back to the Salesforce example, you could see that. It's really useful for improving and distributing access to information. One of the reasons why we built it as a university internally was simply just to address sort of a problem we had noticed where a lot of departments can be siloed. And if suddenly we can open up these systems to everybody, there's a lot of tangible benefits that can happen across entire organizations as a result of improving the flow of information. Targeting marketing content generation. I'll show you this example in the demonstration, but what if I have customer data and I want to encourage somebody's business, but I don't want to write the email? Or maybe I have a draft of an email, but I want to incorporate their information. Could I ask it based on this data, could you combine this with my email prompt and write me an email to encourage somebody to continue their business, right? Targeted content. And again, summarization or interpretation, you guys have just seen that. And there's more, right? I'm just touching on the surface, right? I'm just trying to get the brainstorming process flowing to give you guys some ideas on how to actually start building with these applications, right? And again, talking about access to information, it sort of solves that or reduces the cost of that. And again, that means the same thing, right? Improving the cost of information. So this is my design of how I built one, and this is the one we have at the university. So this is by no means the definitive way to do this. But this is just something to you guys thinking about how you could build with these, right? So what do we need in a chatbot, right? Let's remove the LLM. What do we need for a chatbot? We need an interface. We need chat histories. We need some way to view previous messages in the conversation through context. Do we want to support rich text? And then, for example, do we want suggested replies or pre-built prompts to respond or to generate questions for us without having to think about them, which there's a whole ethical discussion there. But and again, we need to tie this back to engineering, right? There is a supporting web app infrastructure that needs to power all of this, right? We need authentication mechanisms, right? Because data leakage is a big thing with LLMs, right? To make sure people are authorized to access this information. They're authorized to ask about that information, right? And then again, your web server and content delivery choices. So some technologies you really need to get started with this. They provide so many SDKs. When I actually first started building with it, they only had like a Python and a JavaScript one. I found out somebody created an OpenAI package for PHP. Right? I love PHP, but I was like, man, that's awesome. I didn't think that they would make one for PHP. You'll need a stateful front-end framework, your flavor of JavaScript or whatever you like. You could do a full-stack application like Ruby or Django, right? We just need the infrastructure to be in place. We need a database. The database is required to store conversation histories and to kind of support that authentication mechanisms. You could do a Redis cache if you want, or another caching system, but that's more so for conversation to make it quick and easy to access and to speed up the application. And then you have your model choices, right? There's major LLMs like OpenAI, Google, and Anthropic. I would argue that they're the leading companies, right? But they have really good models. There's also local LLMs, and there are some packages that let you experiment with them. And I was going to go more in depth here, but I feel like for a lot of people, it might be easier just to get started with an LLM that's online, because calling an API, I would say a lot of developers know how to do that versus installing, what's the package name? There's a Python package name that you have to learn how to use, and then you have to find a model, and there's a whole lot of information with that, that you have to kind of vet in order to make sure you're not just downloading random stuff from the internet, So here are some design guidelines that we kind of figured out, and you guys will probably resonate with. Right, object-oriented, right? If we just have a chat thing, sending chat messages is really reusable. Object-oriented shines. Code modularization is critical. And so I think I'll talk about it on the next slide, but the big reason for that is so you can organize your code, obviously. But really to focus on the LLM provider thing, right? You don't want to get tied to a provider, right? That's something that people sort of, I think, are glancing over right now as they build applications, because what if OpenAI raises their prices? Right, I think they just put out a roadmap, ChatGPT, by $44 a month by 2029. Are you comfortable paying that? Are you comfortable with your business paying that? What happens if they cancel your account? And this is a business-critical application, right? Those are important questions to kind of consider. And again, do you want a monolithic or microservice approach? This is kind of the flavor of your organization or your personal development style, but still important questions to consider, right? What we found is that queues and parallelization are really valuable. So this advisor dashboard project we did, we have it process, I think, 10,500 students. and we have it generate a score and a summary for 10,500 students. That takes a lot of time. I think the first time we ran it, it was estimated to take 37 hours. And then we optimized our code, 6 Redis queue workers, and we got it down to, I think, our AI script now only takes about an hour and a half for 10,500 students, and that's pretty fast. And if we continue optimizing it, right, it's pretty usable right now as it is, right? And I'll highlight the only reason I bring that up is because, right, the blocking nature of HTTP calls, right, they take time, network latency, all that good stuff. So pipelines, right? This is another question that people are kind of wrangling with, right? Should the LLM generate your SQL code for you? I don't think so. That makes me uncomfortable. I like to pre-format, because one, I know that the data is going to come back in a specific format, but two, what if you have a view that has like social security numbers in a personal customer database, right? And it just puts that in there without thinking, and then data leakage, right? So platform service models, very similar across the board. They do rate limiting. They do it by tokens, right? This is why I defined these terms at the beginning, right? So they charge you by the token. As you go to, it depends on the model, what your rate limit is. There's tiers for organizations. I think OpenAI is like $5, you get moved to tier 1, $25 tier 2. I think to get to tier 5, you have to spend $1,000, which isn't actually that much for an organization to spend. But just to kind of give you guys a look into it, there's pricing. You could just Google OpenAI API pricing, and you could get, the information. Right, and again, you get billed by tokens, right? So for ChatGPT 4.0, for per million tokens of input, costs $5. Per million output, it's 15, right? So that's why tokens, like, this is an important thing, the business terminology, right? Because it's like, if somebody asks you, I want to build AI, and they're like, well, how much is it going to cost? Well, we got to kind of estimate our token usages, how much people use it, and so on and so forth, right? And again, just questions to consider, right? These are just development questions. How many users do you need, right? That'll inform your infrastructure choices. How fast do you expect it to be? Do you need a cache? Do we need one? We don't need one, but it'll make it faster. And how complex is your data? That's a big one, because when we started working with all these data sets where I work, we ended up finding that there's a lot of data that there might be codes or shorthand versions of information, and it's like, if I just look at that data, I'm not going to know what it means, right? That's a complexity I need to go kind of solve before we get that far. All right, and what are the high-level goals of this kind of chatbot system, right? We want intuitive, real-time access to data. We want it to be fault-tolerant, secure, scalable, high confidence in information accuracy, right? Because if this is the authoritative source of truth for people to start referencing instead of using, Salesforce, for example, we want it to be accurate. That's just a really important consideration, right? And minimizing, hallucinations. So extremely high-level system architecture, right? So let's flesh this out. At the basics, we have our LLM API, right? Our LLM API. We have a server that handles requests, and we have a user. The user asks a question, goes to the AI. The output goes all the way back to the user. If we add database and caching, we still have the user ask the question, goes to the server, our backend infrastructure, goes to the LLM, it responds. We log the user's question, we log the AI's response, any other associated metadata that we need, and then we return the question to the user. But how do we get our data in there, right? This is the problem that we sort of solved, and that's what you're going to see how we solved it, but it's not quite clear where we can inject it, right? We can maybe inject it here, but then how do we know the server just off of a question? How do we map that, right? Because it's unstructured data. I don't know what the user's going to type. I can't do a string search, it's kind of rudimentary for our purposes. So just touch on some advanced designs, because these will be important for how we structure our chatbot. So multi-agent systems, multiple models are discussing an answer before they reply. Model, LLM, interchangeable. You just have it give feedback before it actually, it can ask, it can provide feedback on itself before responding. Multi-agent system. And then retrieval augmented generation, applications combining data and prompts for interpretation, which is what we're going to focus on if you couldn't tell. That's going to be our big one. But again, just giving the terminology to discuss some of these concepts, right? So what are some abstractions we need to do that sort of retrieval augmented generation? How can we fetch relevant data, right? If we have an unstructured input, how do I know what data you need? You could ask me, well, I want to know what's the student's email, but then how do I map that programmatically? Right, that's sort of some of the questions we confronted when we were dealing with development. We need to determine their intent and what data they're seeking. Right, and mapping, so what we decided to do was we decided to map the data to user queries. And I'll get on how we did that. But to do this requires a list of data sources or a list of functions that call SQL queries and return data, right? That's one way to think of indexing your data sources. And it's, again, do we want to collect individual or target data points, right? Then we need an identifier, right? So select all receipts from customer database where username Jane Doe, right? That's an identifier we provided. So what if we want targeted data now too, right? Not just some data we have kind of in the backend databases somewhere. So to sort of walk through some of the code and system, right? This on the left is how you call the LLM. That's it. It's just you could call that a ChatGPT wrapper. I'm okay with it. But you just define, remember, temperature, how creative the model will be. We specify the model. In this case, I'm using 4.0. And we give it the system context, right? So this is the prompt that will basically inform it on how you want it to respond to the conversation. These are all adjustable, right? You can just change the inputs to the function. And again, we have just a send chat function here, right? So this sets us up when we instantiate the class. When we send a chat, we just need the chat message and the context. If there is no context, we use the default. But this is it, right? We have a role. The system provides the system context, role, user, content, chat message, their question, and then you return it. You could literally do this in probably 40 lines of code. That's why I want you guys to experiment, right? This is not complex stuff. It might look complex at first, but the SDKs they provide is really to get people on board as fast as possible. So again, to discuss more about how we fleshed our system out, right? So we decided to ask a model, we called the API, asking the model, to match a user's question with a relevant data category. So categories can be associated with databases and retrieval functions, and they can be evaluated on the model. And I'm going to jump one slide just so you can see this, right? So here's my prompt. Based on the following question, I need you to return a single keyword from this list. Try to select the one that matches the most reasonable interpretation behind the content and intent. Don't respond with anything else, right? So we're formatting the response. What kitchen utensils used to flip pancakes was my question. What are our keywords? Cooking, baking, and eating. Now, some of you might have some different thoughts on this question, right? So there is some variability. But if you define it enough, I think cooking is probably the best choice, right? What have we done here, though? We've basically formatted the AI's response. We can search that string, right? So suddenly we've taken an unstructured question and we've made it the structured interpretable, right? Because we can go find data the user needs now. Jumping back a slide. So basic text searches can be performed on that to trigger function calls, right? So if I have a method wrapper on a database function call that triggers a SQL query to return some data, we can now do that just by mapping a keyword, right? Sort of an abstraction there on how to determine the user's intent. And here's my example. This is the programmatic interpretation, right? I have a function called check keywords, cooking, baking, eating. We check each of the cases. If it's cooking, we'll retrieve a list of cookware, and you can fill in the blanks on what you want to actually do here. This is sort of an example, right? Or if it was baking, we can get a list of baking stuff. Eating, we could get a list of cutlery stuff. But you can see how this could be abstracted into customer data or certain segments of data if you sector it off. And again, here's the function, right? Select all from kitchen tools. Again, this is kind of pseudocode just for a high level. But this is how we sort of mapped it, right? We assigned a keyword to the query, and based on this, we return the data. So it's a multi-agent system, right? So we can retrieve actually a lot of data this way, right? Because suddenly we've opened up the floodgates where we can have multiple SQL queries fire if the model returns multiple keywords, right? And so if after the data retrieval, how we actually get this to the LLM is we just combine this data with the user's question, right? Because you saw earlier, remember that JSON packet? That was, it might be hard to read at first, but the LLM doesn't care. It'll read that and parse it in about 1 second, right? It has no problem sifting through that data. Right, and so you could continuously ask more models to ask data if you need to, right? So if I have 20 keywords that get returned, 20 queries, I can have the model summarize these for me before even getting it back to the user's question, right? So we had seen how I'd asked about the customer's receipt. What if I had 2 receipts? I want them to be summarized independently, and then I want those summaries to be appended to a user's question so that I could answer the question about maybe those receipts, right? And again, the reason for doing something like that is sort of limit token costs and other stuff like that. But you can also sift through the summaries as well and see if there's anything in there that you might want to change or something like that. And again, I'll show you that in a little bit here. And then eventually we just return the model output, right? So here's an example where we still use the send chat function, but now we want to process this returned SQL data, right? I gave it a context of you were a friend, but based on the attached data, can you generate me a report on this, right? And again, we could have multiple functions that call this. They just get passed different data, right? So we sort of, do you guys see how powerful this sort of abstraction is, where we can kind of figure out what the user wants, but then also map it to data and still have their question get answered with that data, right? Isn't it kind of cool? When we figured this out, we were like, man, this is a cool abstraction to kind of play around with. So, but wait a minute, right? So I want specific data, right? What if I want just to query about a restaurant's inventory, right? I know the restaurant's ID. Maybe I have a franchise of 5 McDonald's restaurants, right? I know this ID for this McDonald's. But how can we perform a targeted data lookup? All we do is we just change our queries to receive an ID, right? In our cookware and restaurant ID is equal to our restaurant ID. We just pass the identifier in, right? So remember when I said Jane Doe was the identifier earlier? In this case, it'd just be an ID. And again, in our keywords, all we do is we add that as a parameter, right? And so all we need to do is pass in an ID to these SQL functions, and we get specific data. Now you might ask, well, how do we do that? Well, when a user logs in, right, what data do we have? We have their username, we have their email. But again, it's like, there's another abstraction here, right? It's like, well, what if I'm an administrator and I want to ask data about any of these people? If I'm an administrator asking questions about students, what if I just have a little chat box that says, please enter the student you'd like to look up? Suddenly you've created an opening into 10.5, like in our case, 10,500 student records to go fetch data dynamically, right? So this is the high-level abstraction of how we're actually doing this keyword mapping. The user asks a question. We give an LLM agent their question and the keywords. We return the keywords. Based on the keywords, data sets can pull in institutional data by running SQL calls. Or I know I keep talking about SQL, but if you're, whatever flavor DBMS you like to use, but it'll return data. If we combine that data with the user's question, suddenly we have an informed data response, right? And that's a really powerful thing, right? Because talking about user license counts and all that other good stuff we just talked about, we've abstracted away all of that. And suddenly if I don't need to go train on that system, I can just ask this system, how this works, right? So here's our high-level app logic, right? User logs in, return a list of conversation IDs. This is more about the chatbot. The user can create a new conversation, or they could select one that exists. You just log and then when they send a new message, you log the inbound message, log the outbound AI response, store the conversation in the database, or just store it in Redis, whatever you'd like to do, or cache, and then response messages are obviously returned. So I built a chatbot, and I want to show you guys, because this is sort of to drive home the work we did. I haven't built 210, right? Okay. So, oh God, I might have to refresh the page. So, here's some data, right? You don't have to memorize this because we'll refer back to this. But you can see it's just some customer information. It's not real, by the way. It's ChatGPT this to generate, so no privacy concerns. But right, so what I did here was I built a really basic chatbot. Demonstration luck, please. If I refresh the page here, right, I just defaulted. This is an MVP, right? Jane Doe is my username. You could just say welcome them. But I can select a customer ID. And then I can ask questions about them, right? So what is everyone's favorite customer today?
Michael Brown.
Michael Brown. All right, I just hit enter. What can you tell me about this customer? And it'll take a second to reply because I'm using ChatGPT 4 for this. There we go. Mr. Michael Brown has been a customer of their service since November 30th, 2019. That's his email, his contact number, and his address, and his postal code. His most recent purchase was on March 10th. Let's look at this one by one. Has been a customer with our service since November 30th, 2019. Can I do this? Yeah. Michael Brown, customer since November 30th, 2019. His email is michaelbrown@example.com. His email is michaelbrown@example.com. His contact number is 847-555-4567. 847-555-45. So the data is correct, right? One of the reasons why that this works as compared to asking ChatGPT and it makes up information is because we're supplying the data with the question, right? And that's really important because if you provide it that data, ChatGPT loves to interact off of the data you feed it. So what did we do? We fed it the data and said, hey, can you answer this question? All I'm doing on the back end is running a SQL function and passing it a dictionary of rows. That's it. In this case, it'd be a single row, right, for a single customer. And just to kind of drive home that this isn't, tomfoolery of the highest regard, what's everyone's next favorite customer? Sarah. What question do you want me to ask it? Based off of this data. Yep, okay. How long has this customer, I'll say, been with us? And we picked Sarah, right? You said Sarah. Ms. Sarah Johnson has been a customer with us since May 8th, 2021. Sarah Johnson, customer since May 8th, 2021. Does anyone want to, does somebody want to compose an SMS message? Can somebody give me a question about a targeted message so we can implement the generative side of that thing? I'll give you an example, right? So can you, let's say, based on all the information you have for Sarah, write an SMS message encouraging, let's say, write an SMS message to encourage her to, or we'll say write an SMS message to thank her for being a customer. Sorry, I needed to think about that. So we'll see what it says. I feel like I should put the Jeopardy theme music in there. There you go. Thank you very much for your valued patronage. We sincerely appreciate your trust in our company since you joined us, May 8th, 2021. We look forward to serving you, right? So let's check what date she joined the company, right? This was Sarah. She joined May 8th, 2021. Right. Does somebody want to just come up here and ask a question? You can try it. Or does somebody have a question you want me to ask it? You could, anyone? I open the floor if you have an idea. No, I can't. It's running in a Docker container. Anyone have a question or anything? It's okay if you guys don't. Like I said, I'm not spoofing this. Yeah. Say that again? That actually won't work in this context because how I have it set up is the ID, right? This is a good question, actually, right? So when we provided an ID, we say only look up for this customer. If I wanted to do something like that, I'd have to abstract the ID away and try to match it to maybe an all customers keyword, which calls SQL that doesn't require an identifier. So in this case, that wouldn't work, unfortunately. But that's a great question because then that's a great question. I'm glad you brought that up because you can sort of see into the application now and how these data pipelines are working. So maybe we need to build another data pipeline that pulls in all customer information or can summarize it, right? It might get weird if the data is too complex, too long, but those are just things you'd solve, during the development process. The last part about this thing as a chatbot is there's conversation history. Really basic. Here were some test conversations I did earlier today. Right. But that's the gist of how you could do this, right? You all can actually download this and play around with it. There's a GitHub QR code at the end. I'll share with you guys. All you need is an OpenAI key. You need to fund it with like $5. So sorry. But if you want to play around with it, just Docker Compose. There's some instructions on it you'll be able to see. But if you want to play around with this and kind of work with it, you can do your own thing. There's even a MySQL init file that has some SQL statements that generate all that data for you, that I just shown you. So you can play around with it and see, is this guy pulling my leg? So what are some insights and challenges we had, right? So around implementation, right? Use LLMs to solve problems that require LLM solutions. One of my biggest gripes right now in business and organization is people say, we need AI. We need AI. Strava just added an AI feature to it's an exercise tracking app. They added an AI feature that analyzes your results that nobody asked for and everyone's making fun of online, right? Don't use LLMs to solve non-LLMs, And don't ask developers to either, right? If you're a manager here. They're a great productivity tool and a solution when they're used in the right fashion. But again, don't solve non-AI problems without AI. And don't ask your developers to either because it's like, I want to incorporate this thing, but I don't know how I want to incorporate it, right? You're sort of putting the cart before the horse because you don't have a problem yet that requires this solution, right? As engineers, sort of problem solvers in the room, you'd probably appreciate that, right? So then ask yourself, right? This is an important question. Don't use AI for everything. Can we build it without AI? Would it be faster without AI? Do we need it to be consistent, right? Because we'll talk about model outputs here in a second, how they could vary, right? Do we need it to be consistent, accurate at all times? Are we just creating strings and text, right? Don't fall into that trap of we need it, right? And again, prompt engineering is real. People were like, oh, prompt engineering is a great career now, right? There were a lot of jokes that have kind of played out over the past few months around it, but they can make or break your chatbot, right? What kind of tone do you want from the chatbot, right? How do you like to process information, right? Like I said, I'm a very logical, analytical thinker. I like to look at perspectives and make a decision. Some people don't think like that, right? Everyone has different kind of communication styles. And so, focused and data-informed prompts are more accurate in my opinion, right? If you give it an open-ended prompt, it might not really work as you expect it to, right? Because it might go in a different direction. Different prompts for different data sets. If you had seen back to that SQL example, you can change the context on every single one of those. So if you wanted to highlight specific things, you could tell it, in this SQL data, focus on this column, Try again, right? Prompt engineering, it's not a science. It's literally just try it until it works, try it until it works, try it until it works. This doesn't work, try this, try that, right? Just keep playing around with it. Here's an example, right? So I have some more JSON data, and I said, please summarize the following data. This revolves around a specified student's course registration, provide a detailed yet brief summary. I have the exact same question and data on this side, but all I did was I changed one word. Please provide a detailed yet brief summary. On the right side, please provide a comprehensive yet brief summary. And look at how different our responses were formatted. It's important, right? Because you got to think of the LLM as sort of a natural extension of communication. If I want it to respond in the way that I want it to, I need to tell it to, right? To respond in that fashion. That's why prompt engineering is a really, really important thing. So a few concerns, right? They love to make up information. One thing we learned really early on was we had a SQL function that wasn't actually returning data sometimes, and it would literally just make data up. So yeah, there are some challenges, right, to be expected with some of these things. Right, we want it to be specific enough to discourage jailbreaking, but broad enough for different use cases. Right, you want it to think creatively, but within certain boundaries. And then data challenges, right? Is our institutional data accurate? Is it accessible? Are we understanding it in the right context, right? Because there was something we learned that the word persistence in our institution has a specific organizational business meaning. When we were talking to people about this term, they told us that. And then when we were trying to build, like I said, this dashboard project, we sort of ran into this wall where people were like, that's not what persistence means, because we were using it in a different context. So are we evaluating data in the correct context in business operations or organizational context, right? These are important business questions, right? Touching back on use cases. And again, is it easily accessible? Something else you'll learn, or not learn, sorry. Something else you might run into is the data accurate, right? Something we found out was there are a few errors in our data sets, not major, but still things that we needed to correct. So this actually has a side effect of cleaning up your institutional data, which honestly is a win in any context, right? A few more concerns, right? The content is not guaranteed to be consistent. If you use Gemini's models or Gemini's API, it's different than OpenAI's. We found that out the hard way, right? And model updates can cause unexpected behavior. That's why the APIs they provide, for example, OpenAI has GPT-4o latest. I think they have GPT-4o August 8th, 2022. You can specify it before they made a major revision, right? Again, platform dependency. We talked about this earlier. What if they change on us, right? What if they raise our costs, cancel our account? As business leaders, we need to consider these things, right? About, we don't want to put all our eggs in one basket and they pull the basket out from under the eggs, right? That's a weird analogy. But these are important questions to consider, right? And then, are we subsidizing somebody's ChatGPT experiences? What rate limits do we need, right? Remember that Chevy GM example I gave? That's somebody using it like that's their own ChatGPT instance. Who gets access? Is it internal or external? There's certain considerations like that, right? Data leakage is a big one, but again, we have to make sure that this system is airtight security-wise if it's external facing. Is this a new business critical function? If suddenly this is an authoritative source of truth for businesses, there's uptime requirements now, right? So again, I'm just trying to get these bigger picture concept ideas in front of you guys, because if you build with these are things you're going to hit like a brick wall, especially if people love the idea and suddenly it's super important, right? Again, privacy policies, right? So OpenAI right now, I know for a fact says in their API or their policies that they do not currently store or will ever sell your data. This is something, if you're a business leader, you need to keep a close eye on, because what if they do and suddenly some data you're subsidizing, you weren't anonymizing it correctly, right? Something I didn't touch on earlier was that data in the chatbots, you can anonymize it, right? Where you just give it the data without a name, ID, email. Just here's some data, summarize. Here's a list of grades. That's anonymized. But what if you didn't do that and suddenly they sold that data, now somebody's student grade data, which is privileged information, is out there, right? Privacy concerns. data stewardship and leakage we talked about, and then the infrastructure costs, right? LLM APIs cost money. If you run your own local models, that costs a lot more money. So just things to consider. And so a few final takeaways, right? My intent for this conversation is to just get everyone thinking about how we can start building these applications. It's not going away, right? People can hide from it. I know some developers are like, well, AI will never take my job. You can't say that with any certainty, right? Nobody can say that with any certainty. You heard in the keynote about how much he talked about how predictions of how he was going to succeed with his papers and everything were proven wrong because he was wildly successful and they thought he wasn't going to be, right? So we don't know how this thing's going to shape up. So just keep experimenting with it, right? You might hit the honeypot and get the next big idea, and suddenly if you have an app that's pulling in $10,000 a month and you can quit your job, you build more AI stuff, right? That's a little bit of an exaggeration. But get on the train before the train leaves the station, right? And again, remember, they are not black boxes of information. They use pattern recognition, right? They don't have inherent information. And build these with purpose, right? Don't try to solve non-LLM problems with LLMs, right? We want the right tool for the job. I wouldn't try to build a backend. Well, that doesn't work. I was going to say you can't build a backend with JavaScript, but then I forgot that Express is a thing, so never mind. But you get the idea, right? And again, modularizing your system to prevent dependency concerns. Prompting is important. Costs are important. And again, these are the questions I wanted you guys to ask, right? So throughout this presentation, I kind of walked you how we built a chatbot and things to think about as you're building internal applications. Do you think that AI will be revolutionary or transformative? Do you think it'll be your everyday assistant, or do you think it will replace the way of life as we know it today? How do we integrate it in appropriate ways across our applications, right? And again, what problems does it solve, right? Because you might think of the next problem that this solves. Maybe it's not a generative AI chatbot that pulls in data, but thinking about how we can incorporate this technology, you might, like I said, strike gold, and you might have the next $1 million idea. That's not an unrealistic expectation at all, right? So that's my final slide there. If you'd like to learn more about me, I'm just me. I'm not very special, but there's my LinkedIn. If you want to access the GitHub code, you can scan it there and download it. Like I said, there's some instructions there. You'll just need you'll need a Docker installed. You'll see it, Docker Compose, and you'll need an OpenAI key. And if you want the presentation slides, which that contains these QR codes, you can scan that too. Cool. Yeah, that's about it for my presentation. Thank you all for being here. It's kind of an honor that you guys thought this was an important topic for everybody. If there's any questions, I'd try to hopefully answer them if anyone has any.
So you're using models essentially, like you said, they're almost having a conversation.
Yeah.
Like you send it through, and then that communicates with another model that decides sort of what sort of calls you're going to need to make to your database.
Yes.
So my only worry would be that you're multiplying your token use. Has that been an issue for you guys? That the fact that you're using 2 or maybe even more, like essentially calls to OpenAI or your LLM's API for every request?
That's a great question. So we haven't seen the token cost be an issue at scale yet. So we have like a beta testing group where they've been playing around with this, 10 to 20 users. They've had pretty good success with it. That is a consideration though. For our purposes, the reason why we ended up doing the LLM decide what data to get right through those keyword kind of abstractions was simply it's the quickest way for us to determine it, right? We could build some kind of text matching engine or something like that, and you could do that. At scale, that would definitely be a solution that would be investigated. But for us, it was really easy to sort of bootstrap that because then it certainly just started working. If that answers your question as best I can. Anyone else have any other questions?
How'd you solve the issue of making up things when you didn't have data?
We made sure it had data. So what we did was we did some try catch loops, or try except in Python, where we would make sure that the data wasn't null, that the data return wasn't empty, and if it did, we would just return an end user message. Sort of a hack fix for right now, but we just return an end user message saying, hey, there was an error in the processing. And then when they talk to us, we can obviously go into logs and actually look at that. Depending on how your logs are set up, you have a window into how this thing thinks, the application thinks, if you will, and you can sort of take a look at issues like that. What we actually tipped us off to was we would put in an identifier, and we knew the data, right, for this person, and then it would spit back like completely unrelated information. And we're like, what is going on here? So we spent like a day looking at it, and then we're like, wait a minute, let's go see what data is being returned. And then we found out, Python's an empty list. And so we were like, okay, this thing's just making stuff up. That's why it's, data sanitization in these pipelines is pretty important. So,
Given that LLMs are primarily like next word prediction models, is there any actual technical distinction between what is a hallucination and what actually is real information? And if so, how do you, like at a technical level, how does the system know if it's hallucinating?
Great question. It doesn't. As humans, we label things as hallucinations. The model does not know any of that, right? It just says, okay, based on this word and these other words, I think that the next word is this one. And it repeats the process. Based on this word, these words, and all these other ones, I think the next word is this one. It never at any point does fact checking on itself. Never. And there's some models, I think for the U.com presentation, they might have some that actually do fact checking. But if you just open up ChatGPT, you open up, well, Gemini has some search capability. So if you just open up ChatGPT, right, and you type in, give me cases for this, it never verifies that information. It's just generating it, you know. So that the hallucination label is literally, I don't want to say a human abstraction because that's really dehumanizing, but like it's sort of an abstraction that we've done to curate and label this data. Yeah.
So we talk about the need for accuracy with the responses for these chatbots. What level of accuracy would you expect from a chatbot for it actually to become like critical infrastructure in a company or to be like customer facing? And are there actual language models that have achieved that?
That's a great question. I'll be honest, for the last part of the question, I don't know. So for the specific language models that have solved that, my only thought there, and I'll answer the first part of your question, my only thought there is that more better trained models and more tokens and how they've been trained, parameters, they'll sort of minimize hallucinations and falsehoods kind of naturally. But for requirements around accuracy, right, that's sort of a business decision. But obviously, like I said, it's really paramount that for example, say we have a customer-facing chatbot. If they ask an information about their record and it's wrong, it's like, that's going to be a very uncomfortable phone call. So that might be a situation where maybe we don't use AI for that, and we can still do some kind of lookup, but then we just return some formatted strings, right, with some data. So again, use cases, right? It's a good question, but that might, if you need like 100% accuracy in all situations, I wouldn't go with this approach. I'll be completely honest, because there's still some room for error, right? And the models can kind of generate sometimes random outputs. Well, not random. I'll say misled outputs. And in terms of a percentage that is required, I don't have a definitive answer on that. What we were looking for was 95%, right? Because with people beta testing this in our institution, is we still have the people that we have testing this have access to the data. So if worse comes to worse, they can still verify that. In some cases, they were looking at the response and verifying the data. So that's sort of a business or institutional question where, is this going to be used for business decisions, or is this going to be used to give overview of support cases, to maybe your support staff, It sort of depends on the context and the usage requirements that you need. Does that answer your question?
Yes.
Okay. Any other last questions that I could do my best to answer? Yeah.
I apologize if you covered this. I'm going to step off for just a second, but you were demonstrating connecting to ChatGPT's API.
Yes.
Have you experimented with connecting to local models using something like an Olama server where it has ChatGPT compatible APIs? And if so, are you running into issues where those models just don't have some of the technical capabilities that allow you to perform what you demonstrated?
Yeah, so I've played around with it. I'll be honest, I haven't built something in like a true beta or production context. There's a package, LangChain. It's called LangChain. It's a Python package that lets you actually interact with them locally like that. So I've experimented with it. My only concerns with that are, one, like you had said, some of those models are not very powerful. And the more powerful the model is, the better the response is. It's sort of, I don't want to say it's linear, but it's sort of like that. So I would expect that if you do run your own local models, unless you may be running the 70 billion Llama open source V2, I think they just released V3, I'd expect if you're running something that's like an 8 billion parameter model, you might actually encounter some more significant issues. The only reason I think we didn't run into so many issues is because we were willing just to play around by paying for the OpenAI APIs. And that's why I think getting started with those, because then by getting started with the really, I don't want to say really good models, but if you start with the really good models, then when you start playing around with ones that maybe aren't so good, the distinctions stand out, right, immediately. So that's a way you can kind of sort of differentiate, what you want to actually use in your business or in your personal projects or so on and so forth. Yeah.
And they don't want to spend money on
Yeah. Yeah. I'll just add one note on that. So I think you get free credits. I'm not 100% sure. I only loaded my account with $5, and I think I've spent maybe 20 cents. So you can create an account. I think the minimum is 5. If you just do 5, get a key. You could play around with this demonstration. You don't have to, but like I said, it's like a $5 for 1,000,000 tokens. All the tokens we did there was like maybe 1,000. We still have to 100x that? Yeah, 100x that. So just to add some more clarity around that. So cool. Well, I think that about wraps up how much time I had. So like I said, thank you all for taking this. It's an honor that you guys think this talk's impactful. I hope that you kind of got some business considerations and some use cases and some other really important information so you can start playing around with these technologies. So yeah, thank you. I really appreciate the time.